everyone. Today we're looking at notes 5-7, converting from standard to vertex form using completing the square. So in your last lesson, you took a quadratic that was in vertex form and you actually put it into standard form. But in this lesson, we're going from standard form to vertex form using a process called completing the square. So let's get started. In lesson 5-1, which that was 2 lessons ago, I believe, okay, we learned that we can easily draw the graph of a quadratic if the equation is in vertex form. Okay, so like I said, lesson 5-1, we learned about vertex form of a quadratic and how to graph a quadratic when it was written in vertex form. So just a quick recap of that lesson. All right. So in lesson 5-1, we learned that we can easily draw the graph of a quadratic if the equation is in vertex form because we can get the vertex, of course, okay, the transformations, okay, so we knew how did the graph shift, left, right, up, down, stretch, shrink, reflect, etc. So from vertex form, we can get the vertex, the transformations, and we can tell if the vertex is a min or a max, okay, remember, from the equation. So remember, based on this equation, because that a value is less than 0, we knew the graph opened down, therefore we knew the vertex was going to be a max. Okay, here, this a value was greater than 0, so we knew the graph opened up, and then we could tell that the vertex was going to be a min. We could have told that without even graphing. Okay, so if the equation is in standard form, we can tell if the vertex is a min or a max. You remember that? So let's refresh real quick. So standard form and vertex form both have this a value in front. And if we're talking about the same equation, then the value for the a value will be the same. So if we're talking about these two equations are the same, all right, then if this is 3, this will be 3. If the a value here is -2, then the a value here will be -2. So when the equation is in standard form, we can still tell if the vertex is a max or a min or a max, because we can look at that a value and know, does the graph open down or does the graph open up? So we can tell if it's a max or a min, and we can get the y-intercept. Remember, the y-intercept is this c value that hangs off the back here, because remember, to find a y-intercept, you plug in 0 for x, and if we plugged in 0 here in this term and we plugged in 0 here in this term, both of those terms would turn to 0, so all you'd have left is c. So we know that we could get the y-intercept, however, we cannot get the vertex. So in standard form, we know if the vertex is a min or a max, but we can't tell exactly at what value because we don't have the vertex. So it's definitely easier to graph when the equation is in vertex form. So that's why we would want to take a standard form quadratic and put it in vertex form, because you might want to graph, okay? You might want to see the transformations. You might want to see the vertex, etc., the axis of symmetry. Okay, so that's why you would want to do this. So to convert from standard form to vertex form, so going from standard to vertex, you use a tool called completing the square. Okay, and it's not bad, I promise. So examples, use completing the square to convert from standard form to vertex form, then state the vertex. And even after that, we'll even check our work, so just so you know. So I just have the vertex form here so we can easily see that this is our goal, okay? We're given these 2 examples, both quadratics that are in standard form. So ax squared plus bx plus c, okay? Y equals ax squared plus bx plus c. And we're converting to vertex form. So here's a couple of things we know. So right off the bat, we know we're going to have y equals. We know the a value in standard form is the same a value here in vertex form. So here, if my a value is 1, then my a value here is also going to be 1, so I don't need to put it, it's implied. Okay, we know that x is going to remain x, so we know that this x is going to stay here. That's true. We know we're going to have a quantity squared, and we just don't know the h and the k. So how do you go about finding those? So it's a process called completing the square, and like I said, it's not bad. So what you're going to do is you're always going to take half of this b value. Half of this b value, as long as you factored out the a value. And we'll get to that in the next lesson. We won't have to worry about it in this lesson. Okay, so take half of the b value. So plus 3. The b value here is positive 6. So half of positive 6 is positive 3. Okay, you always drag down this number here, and then let's talk. So off to the side, and I don't expect you to do this every time unless you're struggling, okay? And I won't do this every time, but I want you to see. So if I go off to the side here, and if I if I take this quantity squared, x plus 3 times x plus 3, and I multiply, okay, what do I get? X times x is x squared. X times 3, 3x. 3 times x, 3x. So that combines to 6x. And then 3 times 3 is 9. So when I double distribute this term to both and distribute this term to both, this is what I get. This is great. I want these two things to match. I want those two terms to match. This is great. I want these two terms to match, okay? Remember, I can't change the equation. I can just change the way it looks. So when I multiply back out, I want it to give me back to this problem. Okay, so I've got these match, these match. I've already taken care of making sure these match, but I've got this extra 9 here, and you'll always have this extra number because you created this quantity squared. And unfortunately, this is really the only hard part of this assignment, is you've always created this extra number, and you absolutely cannot forget to undo it every single time. So undo it by performing the inverse of positive 9, which is negative 9. Okay, so whenever you multiply this back out, okay, you get plus 9. You don't want plus 9, you want minus 6. That's why we kept it. Okay, so to undo the plus 9 that you get, you minus 9. Okay, so then let's go ahead and finish off our vertex form. So we get the quantity x plus 3 squared, combined like terms, so negative 15, and that's it. Now it did say to state the vertex, so that would be negative 3 comma negative 15. So this would be your answer, because that's what it wanted. It wanted us to take the standard form, put it in vertex form, and give the vertex. So I've done that. But then for me, I want you to always check your work. So in a different color, so we'll use pink, I guess. We'll check our work. Okay, so what does that mean? That means, that's a check, not a V, not to be confused with the V for vertex. So we're going to take this equation, y equals, I'm going to go ahead and expand the x plus 3 squared, the quantity x plus 3 squared. So take the quantity x plus 3 twice, that's what the squared means, and the minus 15, and let's just double check that this multiplies back to the original problem. So y equals, again when I FOIL, x times x, x squared, or double distribute, whatever you want to call it, and then, so x squared, and then 3x and 3x, so that combines to 6x, and then 3 times 3 is 9, and then drag down this minus 15 here, so you get x squared plus 6x, combine these two terms, and what do you get? You get negative 6. Well, look at that. That matches the original problem, so check and check. So we have checked to make sure that the vertex form we created matches, whenever we expand it and multiply out, it matches the standard form that we were given. So that's great. Okay, so let's do another example. All right, so here's example number 2. So on example number 2, again, y equals, okay, we know the a value is 1, so therefore the a value is going to be 1 here, so we don't need to write it. We always know that x is going to stay. We're going to have a quantity squared. Always drag that the c value down, okay? We want it to match. How do we get this number in here? Do you remember? We take half of the b value. What is half of negative 8? It's negative 4. Okay, so half that value. Then, if you need to, come off to the side. But y'all, I'm just going to tell you a little trick here. How you get the number that you undo out here is always going to come from this value squared times the a value. All right, so negative 4 squared, which is 16, times 1, which is still 16. So that 16 is that extra value that's created that we don't want. So 16 is the extra value, so we need to subtract 16 to get rid of it. But if you don't believe me, if that wasn't enough and you need to see it, then come off to the side and actually make sure. So x times x is x squared. That's negative 4 and negative 4, which combines to negative 8x, and then positive 16. So just like we said, the value we needed to undo is 16. So we did. Okay, we subtracted 16. And again, how you get that number is you take this value, square it, multiply it by the a, and then undo it by doing the opposite. Okay? All right, so let's move right along. So we're almost done. We have the quantity x minus 4 squared minus 36. Our vertex would then be 4 comma negative 36. I told you this process is literally so short. Okay, and then we need to just check our work. So let's check it. Let's write y equals, let's expand the x minus 4. So we're just checking to make sure the vertex form that we found is going to multiply back to the original standard form. So y equals, when I distribute x squared, negative 4x, so combines to negative 8x, positive 16 minus 36. So y equals x squared minus 8x minus 20. And what do you know? That gets me back to the standard form. So we're good to go.